friends. Today in this lecture we'll deal about inverse Laplace transform. So inverse Laplace transform, the method of finding inverse Laplace is partial fractions. Partial fraction. So when dealing with second order RLC component, you got the system responses as overdamped, critically damped, and underdamped. So how do you get overdamped, critically damped, underdamped? Based on the roots of the characteristic equation, that is I of s or v of s. So based on the roots, we got overdamped, critically damped, underdamped. Since if the system is having real and unequal roots, then it is overdamped. If it is having real and equal roots, then it is having critically damped. If the system is complex roots, having complex roots, then you will got underdamped system. So now we'll solve these three types of Laplace transform. How to find the inverse Laplace transform? So I'm repeating again. So inverse Laplace is a function. If the first initially you will getting a differential function f of t. You will having a differential function f of t. For this differential function you applied Laplace transform, and after inverse Laplace of this you will be getting response f of t. Inverse Laplace, you will getting response f of t. So in this phase, so Laplace transform f of s. If the Laplace transform f of s equal to, suppose 5s 7s plus 2 by s cube plus 3s square plus 2s. So this is the response Laplace transform of some RLC component. Say for example f of s, in case of f of s, it is I of s function. So this is you obtain like this. After obtaining like this, it is if you see, observe carefully, you separate s component below. So you will be having s square plus 3s plus 2. So after seeing this, you will find the roots of this denominator. You will find. So the roots you obtained is minus 1 comma minus 2. So these are real and unequal roots. So for this real and unequal roots, you will find the inverse Laplace as f of s plus 2 7s plus s into s plus 1 into s plus 2. So by applying partial fractions now, so f of s equal to, so applying partial fractions is a by s, each component s plus 1 plus c by s plus 2. So now you will so take the LCM again, and a of s plus 1 plus s plus 1 into s plus 2 plus b of s into s plus 2 plus c of s into es plus 1. Okay. So you got f of s in partial fraction form like this. Now compare this equation with this is 1 and this is 2. Comparing equation 1 and 2, so equating the numerators, you will having a of s plus 1 into s plus 2 plus b of s into s plus 2 plus c of s into s plus 1 equal to 7s plus 2. So after getting this equation, you will equate the coefficient of s here. So if you see, you're having a s square components here and s components here and constant components here. In this you will having only s component and constant component. Equating s square components. So in this you will have a into s square plus 3s plus 2. So a plus b into s square plus 2, b plus c equal to 0. So equating s components now. So in this you have s square plus 3s plus 2. So 3a plus 3a plus 2b plus c equal to 7. So equating s components. Now again equating constant component. So constant components is you having 2a equal to, so in this no constant, here is no constant, 2a equal to 2. So equating these things, these three equations, you will be getting a equal to 1 and b equal to 5 and c equal to -6. So it's equating that, you will get these components. So now you frame these components in f of s. So f of s equal to, after getting 1 by s plus 5 by s plus 1 minus of 6 by s plus 2. So this is individually you got partially you differentiated this equation to this form. So you will find the Laplace inverse of this f of s. So that is f of t. So immediately if you see, you have a Laplace inverse of 1 as 1 by s square, 1 by s. So f of t equal to what? 1 plus, this is in the form of a by s plus a. So Laplace inverse of a by s plus a is a into e power minus at. So e power minus at. So 1 plus e power 5 into e power minus t minus 6 into e power minus 2t. Okay. So this is the Laplace inverse of this function. So you already know, for this solving you need to know the inverse Laplace of a few functions. So already explained in the before section. So 1 plus 5 into e power minus et minus 6 into e power minus 2t. So this is called this is overdamped system response. Okay. Now we'll solve for critically damped function. That is if the roots are real and equal. So for that explanation, I take the function f of s equal to s minus 2 by s into s plus 1 whole square. So this having real and equal roots. So and applying inverse Laplace is s minus 2. So a by s individual component plus b by s plus 1 plus c by s plus 1 whole square. So you will differentiate this one s component like this, b by s plus 1 plus c by s plus 1 whole square. So this is a partial fraction form of if you having multiple roots, say for example s by 2 by s into s plus 1 whole cube, then the partial fraction will be a plus a plus b by s plus 1 plus c by s plus 1 whole square plus d by s plus 1 whole cube. So this numerator having 4 components, fourth order, that is s into s cube. So you will getting 4 equations. Similarly, this is a third order. So s into s square, that is third order function, third order system. So for this third order system, you will getting 3 components. Okay. Now same applying, you will LCM this and you will getting the equation as s into s plus 1 whole square. So individually components a into s plus 1 whole square plus b into s of s plus 1 plus c into s. Okay. Now you will equate this equation with this equation. You will be getting the final equation, equating numerators. So a of s square plus, so s square plus 2s plus 1 plus b of s square plus s plus cs equal to s minus 2. Equating s square component, s square coefficients, you will be getting a plus b equal to 0. So this is having no s square component, and again equating s coefficients, we will be getting 2a plus b plus c equal to 1. So s square component is 1. So constants, again equating constant. So a plus, so a equal to minus 2. So yeah, equating these 3 equations to get ABC. So a equal to minus 2, so b equal to 2 and c equal to 3. So after getting these 3, substitute this in this value. So this f of s equal to minus 2 by s plus 2 by s plus 1 plus 3 by s plus 1 whole cube. So after seeing this, you need to understand the few. So Laplace inverse of a by s equal to a, Laplace inverse of a by s plus a equal to a into e power minus at, and Laplace inverse of a by s plus a whole square equal to t into e power minus at t. So in your mind, you should remember these 3 equations. Okay. So for first order equation, you need to remember Laplace inverse of only a by s and Laplace inverse of a by s plus a only. So you predeterminedly you need to know these things. So finally you will be obtaining in this form. So you will getting partially differentiating the things, you will be getting in this form. So you need to understand the inverse Laplace of this, you need to know these things. Similarly for first order also. Now for this thing, you need the extra inverse Laplace of this form. So basing on these equations, the inverse Laplace f of t equal to minus 2 plus 2 into a by s plus a. Here a is 2 here, plus a small a is 1. So e power minus t plus 3 into, so inverse Laplace of t equal to what? 1 by s square. So t into e power minus t. Okay. So this is on this you can draw it also. So separating e power minus t here, 2 plus 3t. So f of t equal to, so this is a critically damped system. Okay. So we will solve now another form. So now we have completed critically damped and under damped. So now we will solve another. Now we will solve the third form of characteristics, that is complex roots. So for this explanation, I take the function f of s equal to s cube plus 3 by s square plus 2s plus 5 into s plus 2. So if you find the roots of this, you will be getting the complex roots as minus 1 plus or minus 2j. So finding the inverse Laplace for this function is, so you will separate this partial fraction is as plus this component as 1 as plus b by s square plus 2s plus 5 and c by s plus 2. So equating in the LCM, take the LCM of these two, s plus 2 into s square plus 2s plus 5 . So s plus 2 into s plus b plus c into s square plus 2s plus 5. So equating this term and this term, you will be getting the function as s plus 2 into as plus b plus c into s square plus 2s plus 5 equal to, equating the numerator only, so s cube plus 3. So this is s square. So now you compare the coefficient of s square here. So comparing the coefficient of s square, so you will be in this, so you will be having as square plus bs plus 2as plus b plus c into s square plus 2s plus 5 equal to s square plus 3. So comparing the s square components, you are having a plus c equal to 1 and s components 2a, so 2a plus b plus 2c equal to, there is no s component here, so it is 0. Now constants, comparing the constants, so a constant is here in this term, so yes, 2b plus 5c equal to 3. So now calculating these three components, you will be having a equal to minus 2 by 5 and b equal to minus 2 and c equal to 7 by 5. So you will take simply the calculator and go to the equation, equating 5, and this you take second one and you will substitute all these values, you will be getting these components. So substituting in f of s equal to this here. Now this thing, now the main calculation is based here. Substitute a value here, minus 2 by 5s minus 2 by s square plus 2s plus 5 plus 7 by 5 by s plus 2. So you got complex roots. So for the complex roots, that is underdamped system. So underdamped system, in your mind, what is the response of underdamped means cos and cosine forms. Okay, so for this you need to know the inverse Laplace of initially. So inverse Laplace of cos omega t equal to what? S by s square plus omega square. And again inverse Laplace of sin omega t equal to what? Omega by s square plus omega square. And again inverse Laplace of e power minus at cos omega t equal to s plus a by s square, s plus a whole square plus omega square. And again inverse Laplace of e power minus at cos omega t is omega by s plus a whole square plus omega square. So whenever you see the complex roots, then the system is underdamped and the response in the form of cos and cosine forms. So you need to remember initially predeterminedly the inverse Laplace, sorry, so this is the Laplace transforms of these things. So inverse Laplace of this thing is cos omega t and inverse Laplace of this is so if you observe carefully, these terms will be coming in these forms. So the inverse Laplace of these forms is cos and cosine forms. So for that, what you do is initially separate this component quotient. So you need to keep this numerator in s plus form. For that, you take common minus 2 by 5 here. So then this term will be form of s plus 5 by s square plus 2s plus 5 plus 7 by 5 by s plus 2. So now what you will do is, so you need so your denominator should be in the form of this thing. So for that, what is this? 2 by 5 by s plus 5 by s square plus 2s plus 1. So you separate this 5 1 plus in form of 1 plus 4 plus 7 by 5 by s plus 2. Now what happens is minus 2 by 5. So in this term can be represented as s plus 1 whole square, right? That is s plus a whole square. So then the numerator s plus 5 also can be represented as s plus 1 plus 4 by s plus 1 whole square plus 4 can be represented as 2 square plus 7 by 5 s plus. So most of the people will do mistake here only. So they cannot differentiate this. So in your mind, you should be in numerator, you should be understand that this is in this form. So similarly, the numerator also should be in s plus 1 plus 4. So now differentiate this. So now differentiate, not differentiate. So separate these things. Minus 2 by 5 s plus 1 whole square plus 2 square plus 4 can be represented as 2 into 2 by s plus 1 whole square plus 2 square plus 7 by 5 s plus 2. Now compare these things. So s plus 1 by s plus 1 whole square 2 square, and again omega by omega, this is omega and this is also omega. So by seeing a 4 only, so if you see any constant, not only constant, any 4, so you will multiply in denominator with omega, then you will be getting constant here. So now this is thing in the form of this omega by s plus a square plus omega square. Now apply inverse Laplace for this thing. So f of t equal to Laplace inverse of f of s. So the constant will be like this. So this term can be represented in this form. So e power a is what? 2 minus 2t. So cos of omega is minus t, sorry. A is 1 here. E power minus t cos of 2t plus 2 into e power minus t. So compare this equation, sin 2t. Okay. So plus 7 by 5 into e power minus 2t. This is obviously you know that. So for this function, make the constant outside minus 2 by 5 s plus 5, and you need to rearrange this concept in the form of this comps. Initially you need to know this inverse Laplace. So you need to arrange this thing in these forms. After getting rearranging this thing, you will be having inverse Laplace of this thing. So this method why I am doing here is, in calculation of circuits you will be getting circuit like this for second order system. So there you should directly do there you need to remember all these formulas. You will be getting the f of s function in this form, and rearrange these forms to get in Laplace to get these forms. After getting inversely Laplace transforms, you will be getting this one. This is what underdamped response of second order function. Okay. So once we'll list the inverse Laplace of few functions. So inverse Laplace. So you need to remember these formulas basically. So if you know the Laplace of any function, inverse Laplace is also will you know. So inverse Laplace of k by s is k, and inverse Laplace of a by s plus a is a into e power minus at. Then inverse Laplace of as by s square plus omega square. This is a into cos of omega t. Inverse Laplace of a into omega by s square plus omega square, and it is a into sin omega t. Again inverse Laplace of a into s plus a by s square s plus a whole square plus omega square. Then it is a into e power minus at cos omega t. Laplace of a into omega by s plus a whole square plus omega square. Then inverse Laplace is a into e power minus at sin omega t. So you need to remember this inverse Laplace. So you will be applying for complex roots for real and equal. If you have the inverse Laplace transform as real and unequal, you will be using these two formulas. If you are having another formula, a by s plus a whole square equal to a into t e power minus at. So if you are having real and equal roots, so then you'll be using these three inverse Laplace. If you are having real and only complex roots, you will be using this thing cumulatively with any of these three components. These three formulas and cumulatively any of these formulas based on the response only. So you'll be dealing with that in the next class. Directly I'll switch to how you'll use this inverse Laplace, this Laplace transform in the circuits, and we'll draw the equivalent of inductance, capacitance and resistance circuits in Laplace domain. So next class is more interesting. So thank you guys.